Hello, friends. Welcome to Science Talk. I'm your host, Jim Massa. I want to share with you a couple of graphics that our good friend Zach Labe has recently created and shared. And you've seen these types of graphics before. Consider this additional information, updated information, what have you. So, in this first one here, what Zach has done, he has created the temperature anomaly by latitudinal bands. So this is the temperature anomaly. This is the departure, either warmer by up to 2C or cooler by up to 2C, based on the 1951 to 1980 baseline. And basically, this is NASA's data, GISS, right? Now, I'm starting to see more and more analyses going back to the 51 to 1980 baseline, those 30 years. And I agree with doing that because things really started to kick into gear, you could say, by about the mid-1970s, especially with the ocean absorbing a lot of the heat energy. Because as we started seeing towards the end of the last couple of decades of the 20th century is when we start seeing the warming. Now, a lot of atmospheric meteorological analyses do the 30-year average. So they might look at 1971 to 2000, 1981 to 2010, 1991 to 2020. Do that do those analyses and do comparisons to that. But what that tends to do, and I think this is the reason why we're seeing people going back to the 51 to 80 time frame, is that because the planet's been warming, it tends to mask how much warming has actually occurred. I mean, so say, for example, let's say, 81 through 2010, when compared to 51 to 80, let's say that is on average, 1 degree warmer, 1 degree C. And then maybe from 91 to 2020, if that was compared to 81 to 2010, maybe we see a zero point 0.2 degrees C warming. So then you look at that and go, well, it's only, the temperature in 2022 is only about 0.2 C warmer, maybe 0.05 warmer. But then when you compare it back to 51 to 80, then you kind of say, oh, it's a lot warmer. You see what I'm trying to say there? Is that because they're doing the sliding 30-year time periods for analysis, it tends to mask the total warming that has occurred, or just how severe, just how much the warming has occurred. So we're seeing more and more analyses compared to the 51 through 80 time period. So, for example, if Zach wanted to look at the temperature anomaly compared to 91 to 2020, the height of these bars would be considerably less. That's one way. That's kind of way, hopefully, to explain what I'm trying to say here. So, and I think Zach's been one of the people kind of leading the charge, pushing for these kind of analyses, and I think that is appropriate and correct to do so. So what do we see here? Looking at the 3-month period, June, July, and August of 2021. So this vertical line, 0 is the equator. So negative 90, so this is the southern hemisphere. Positive 90, that's the northern hemisphere. So we have Antarctica, about 80 degrees or so to the South Pole. We see that compared to the planet, right? A little cooler, about 1.7 C cooler than the rest of the planet. But then when you start getting to around 75 degrees south latitude, all the way up to the North Pole, we see how considerably warmer the entire planet is compared to this 30-year average of 51 through 80. This low spot here is kind of about in the location of the Antarctic circumpolar current, which is the current that rings around the continent. So it's oceanic. There'll be less energy absorption because don't forget the specific heat content of water. Yes, the southern oceans have absorbed a lot of heat energy, but it's not evenly distributed. And you have to think of the specific heat of water. It takes more energy to heat things up. It's still showing a temperature anomaly. It's still showing warmer than the rest of the planet. Putting aside the 10 degrees of latitude for the Antarctic continent, this has the least warming of the latitudinal band that showed warming, but it's still warm. It's still warmer compared to those 30 years. So this shows, and what do we see over here? Starting about 40 degrees north latitude, but we see the highest temperature anomaly, the highest departure in warming is in the northern hemisphere, basically from temperate to subpolar latitudes. Right up to there. And by the way, these vertical lines here, that represents, this one here is the Antarctic Circle. This one here is the Arctic Circle. And we can see where most of the warming is there. And if you think back to some of the previous videos I've done showing this kind of information, the Arctic is actually even right up to the pole, is warmer than what's been shown in the past. So this is June, July, August 2021. Planet's warming. Now, November 2021, so shortly after June, July, August that we just showed, to April 2022. Basically a 6-month period. Again, we're still looking at the 51 through 80 baseline. Same Antarctic Circle, Equator, Arctic Circle. Right? Southern Hemisphere, Northern Hemisphere. Surface temperature anomaly. So that's a departure from that 30-year average. Nothing on the entire planet is cooler than this 30-year period. Not a single latitudinal band. And look, even the South Pole shows a higher temperature anomaly than what I showed you earlier, but it's even higher than where the Antarctic circumpolar current is. But it's still showing a warmer temperature than the 30-year average. Not as warm, maybe about 1/10 of a degree C. And the scale is different, so it goes up to 0 to 4. So here is, some of the temperate zones in the, like say, Africa, South America, Australia, right? And then look what happens in the Northern Hemisphere. Look at that increase right up to the North Pole. Look at these temperature increases. Look how much warmer this is. This is showing you how the Arctic is 3 to 4 times warming faster than the rest of the planet. Right? There it is, 3 to 4. There it is, right there. And this leads to your Arctic amplification. This leads to increased permafrost thaw, increased sea ice melt, right? There it is. Look at that. This is telling. But not a single latitudinal band shows any cooling departure. Every place on the planet is warmer compared to 1951 and 1980. This is very telling. And finally, surface temperature relative to that 30-year period, okay? And he breaks it down for April 2022, then February through April, so it's February, March, April, those 3 months, and then May 2021 to April 2022. That's basically a 12-month period. Okay, these values is how much warmer for the entire surface of the planet relative to 1951, 1980. So he's trying to basically take these and relate it to, information as we just showed here. So kind of like averaging all of this out. So you can take this latitudinal band, read it across, that's about 1.5. You take this latitudinal band, that's about 2.1, and et cetera, et cetera, and you just average it for the entire global surface. Right? So these are the average temperatures for the particular latitudinal band, which shows a nice breakdown. And then he takes the entire shoot and match, makes an average for the entire surface of the planet to create these. And so let's look at April. So we have a couple places where it's a little cooler on the planet, like down in Antarctica. Now, April, of course, is autumn in the southern hemisphere, leading into winter. So cooling down is to be expected. Okay. Look at North America. North America was the cool spot on the planet. Yeah, you had a couple of oceanic places here. It was a little cooler. That can be accounted for, ENSO events, other physical processes here. Even the North Atlantic, which is typically a cold spot because of, all the meltwater from Greenland and then affecting the air temperature above it, that's not as cool as it has been in the past. So when you look at these places here, it's a little cooler by about minus 0.2, maybe minus 0.6, minus 0.8 C. Okay. But whammo, look at North America. That's like right near the Great Lakes there, or, almost 3 degrees C cooler than that 30-year mean. So North America is kind of the cool spot here. The rest of the planet, we can clearly see that it's warmer. And then look at what's going on in the middle of the Eurasian landmass. It's cooking. Up to 5 C warmer. Look there. You can see right there in the Bering Sea, right? There's the Kamchatka Peninsula. There's the Bering Sea. You see that right over here. That part of Siberia. Extremely warm. And we're seeing what? We've heard about the heat waves that places like India are suffering through. Here it is. It's right there for us to see it. Hot spot right in the middle of the Australian continent. That's April. Now let's look at the 3-month period, February, March, April. I draw your attention to the Arctic. 3 to 4 degrees warmer than this 30-year period. Look at the northern stretches into the Arctic Ocean over Eurasia. We're talking up to 6 degrees C. Right, so these give you a range. 4 to 6 degrees C. 3 to 4 C here. Look at that. Incredible. The middle part of the North American continent is almost about average, in other words, about tracking close to this mean. Tad cooler here, there, up towards Hudson Bay. 0.2 to 0.6 cooler. What we're seeing in the cooler equatorial Pacific, reflected here and here, is because of the La Nina phase of the cycle. So there's cooler water upwelling, and it affects the air temperature. So this is showing a reflection of the La Nina part of the ENSO cycle. Warm Pacific, warm Atlantic, warm Southern Oceans, warm Indian Ocean. Planet's warming. It's right here for us to see it. And then when you look at the 1 year period, Again, we're still seeing that the La Nina signal. Look at the planet. Look at the Arctic. Up to basically, there's none of this, with that light purple, but you have this dark brown here, about 3 to 4C for this 1 year period. So it takes into account the 4 seasons. Look at the North Atlantic. Not as cool as it has been. North Atlantic is warming up. And even so, then the North American continent is warmer. We're talking about the 0.6 to 2 degree warmer. Now, a couple interesting things to note. You see this cool spot here? Cool spot here. This is where the portion of the Antarctic continent where Antarctic bottom water forms. So it's cold, dense water. So the air above that is going to be cooler. So it's not just the North Atlantic, but we also have formed deep water off Antarctica. And that tends to go and fill part of the southern Atlantic Ocean and goes underneath where the North Atlantic deep water comes flowing down. Well, I digress. What I'm showing you here is how much warmer the planet is compared to this 30-year timeline. This is significant. So for April, it was on average for the entire planet 0.82 C warmer. February through April of this year, 2022, 0.92 C. And then we look at this 12-month period, 0.89. Pretty close to this. And this warming is continuing. We see it through the measurements of the annual greenhouse gas index, the Earth's energy imbalance. We're measuring, like how many watts per square meter things are changing. We're doing that. We're seeing that. So we're not only just taking, what is the temperature there, we're then comparing, okay, what does that translate into the watts per square meter? And then how does that translate into the energy imbalance? And the fact is that the absorption is exceeding the reflectance back into space. So in other words, the slope for the absorption is higher than what goes back to space. So it's diverging. So the energy imbalance is increasing. And it's increasing approximately about 1.6 watts per square meter per year. That's a lot. So once again, thanks to our friend Zach Wade, for sharing this with us. And here we're presenting information to you guys so that you can see how drastically things are changing. Okay, an addendum here. In the time when I was recorded what we just saw, Zach Wade put this out. He compiled data for July. Take a look at this. This is even more astounding because keep in mind now, right? July is the middle of the Southern Hemisphere winter. And look what's going on here. Now, the departure from, again, we're talking the 1951 and 1980 30-year baseline. The departure is from 1 degree below that average for that time period to almost 3 above, of course, degrees C. Look at the Southern Hemisphere. In July, the middle of their winter, it's nearly 3 C warmer than this 30-year average. This is astonishing. I mean, it's even warmer than in the Northern Hemisphere. Now, the Northern Hemisphere at this time of year is the middle of summer, so we would actually expect to see a smaller departure from the average since this is the hot time of the year. Even though, let's face it, the Northern Hemisphere has been really, really hot this summer. But even looking at in the vicinity of the Antarctic circumpolar current, which is pretty much around 60 degrees, 55 to 60 degrees south latitude. So this is going to be temperature, above the ocean. It's still pushing almost 1°C. What this shows is that, as we saw in the previous slide, not a single latitude on the planet is even average or cooler than compared to this 30-year average. Everywhere you look, the entire globe is warmer. It is warmer from, about 0.4°C up to 2.9°C for July. Things are really starting to happen. Things are starting to happen. And it's probably going to just keep getting worse from here on out. We've got the droughts, the fires, the hot temperatures, etc. So this just came across, and I wanted to include this graphic, the updated information, to show you just how dramatically warm the planet is getting. And according to the Milankovitch cycles, we're supposed to be entering a cooling phase. This doesn't look like a cooling phase, does it? Quite the opposite. Okay. The latest updated information. Hello folks, this is Jim here with Science Talk, asking you to please subscribe to my channel and to inform others of my channel and of the work that I do. Please share to social media platforms that you use. Also, as a reminder, don't forget to click the bell so that you know when I load up more videos. Finally, I ask that you support the work that I do by becoming a patron at patreon.com. Details in the description box below. Thank you for your support.